This training module describes SELDM inputs for simulating runoff modification by stormwater best management practices, BMPs. This is training module 9.01b for the stochastic empirical loading and dilution model SELDM. This training module has 14 slides and will take about 8 minutes. It was prepared by the U.S. Geological Survey in cooperation with the Federal Highway Administration. This training module has 4 learning objectives. At the end of this module, you should be able to name the 3 BMP processes in SELDM, describe the SELDM approach for modeling BMPs, identify the BMP form and describe the interface, and identify the BMP information in SELDM output files. This presentation is a brief overview of the technical details for simulating BMPs with SELDM. Please see the BMP report, USGS Scientific Investigation Report 2014-5037, and the SELDM Manual, USGS Techniques and Methods Report 4C3, for more details. We will be publishing a new BMP report in 2020 with updated and expanded data and statistics calculated by using data in the December 2019 version of the International BMP database. BMPs affect downstream flows and loads by reducing runoff flows and loads and by extending the runoff hydrograph. The downstream flows and loads are the sum of the upstream and runoff discharge flows and loads. The downstream concentrations are the downstream loads divided by the downstream flows. BMPs can improve downstream water quality when they reduce runoff contributions from the site of interest. BMPs also can reduce downstream concentrations by extending the runoff discharge hydrograph over a longer period of time. Therefore, flow reduction, concentration reduction, and hydrograph extension are the 3 primary BMP treatment mechanisms. SELDM uses a black box approach to model the net effect of one or more BMPs at a site of interest because there are so many complexities. Data for characterizing detailed processes are lacking, and there is great uncertainty in the application of data from one site to another site and from storm to storm. With a black box approach, we are given the flows, concentrations, and loads from the source area and use transfer functions to calculate the flows, concentrations, and loads to the receiving waters. In SELDM, these transfer functions are the stochastic ratio of outflows to inflows with rank correlation to inflow values. In SELDM, the BMP form is the last form before running the model. Once we have the BMP statistics, we can enter them in the BMP form and select that BMP for analysis. Once a BMP is selected, it can be used for other analyses by selecting it from the drop-down menu. This is a screen capture of the SELDM BMP form. The default selection in SELDM is no BMP in place. If this definition is selected, the only tab that is visible is the BMP Overview tab because there are no associated hydraulic or water quality definitions. If a different BMP is selected or defined, the other tabs will appear. The BMP Overview tab has a short name for the combo box, a full name, and a description. The short name is the name that appears in the combo box. The other information is optional. The question mark buttons provide information and definitions. On this slide and subsequent slides, the Edit Current option is selected to activate the input fields. This example is the median biofilter, which represent the median of best fit statistics from analysis of all biofilter sites with paired data in the January 2012 version of the International BMP database. As with the other forms, SELDM has options and command buttons to edit, copy, and define new BMP definitions. The Hydraulics tab has text boxes for the flow reduction ratios and the hydrograph extension times. You select whether the BMP definition has volume reduction or hydrograph extension by clicking or unclicking the associated checkbox. Unclicking the checkbox will delete previously stored values. The flow reduction ratios and the hydrograph extensions simulate BMP outflows from inflows and are defined by the minimum, lower bound of the most probable value, upper bound of the most probable value, maximum, and rank correlation to inflow volumes. The flow reduction values are unitless ratios that must be greater than or equal to 0. The outflow hydrograph extension is in hours and must be greater than or equal to 0. The rank correlations to inflow volumes for both variables are unitless values which must be in the interval from -1 to 1 inclusive. The question mark buttons provide information and definitions. The Calculate Trial Statistic buttons calculate the average, standard deviation, skew, and selected percentiles of the theoretical trapezoidal distribution that has the input values. New values or changes to existing values are not saved until you click the Accept Updates button. The Water Quality Parameters tab is used to view, edit, or create a new definition. The Water Quality Parameters tab has a list of parameters with defined statistics for the selected BMP. The Define New button will activate the Water Quality Treatment Definition tab with blank input fields for data entry. The View Details section will launch a message box with the water quality definition when a parameter name is clicked. The Edit Definition option will activate the Water Quality Treatment Definition tab with populated fields for editing when a constituent is selected from the list. The Water Quality Treatment Definition tab is used to enter treatment definitions. The Select Parameter combo box is used to select the parameter for that BMP. Each BMP definition can have only one set of statistics for each parameter selected. Once you enter the water quality definition, you have to click Accept Updates button on this tab to inspect and save the water quality definition, and click the Accept Updates button on the bottom of the form to associate the definition with the current BMP. Failure to do either will result in a lost definition. This image shows the downstream water quality form, which is launched from the water quality menu form. In this image, the Use BMP Flow and Treatment to Modify Highway Discharge checkbox is highlighted. Defining BMP treatment will change the highway output. To apply those changes to downstream water quality, check the box in the Constituent Pairs form. This option can be used to run the same pair of highway runoff and upstream water quality constituents with and without BMP treatment to see the effect of BMPs on downstream water quality within one SELDM run. All the SELDM output files show some effects of BMPs on flows and water quality. Here are the main outputs. The out.txt file has input BMP statistics. The -HQ text highway runoff outflow file has modified highway flows, concentrations, and loads. The annual load file shows the effect of flow and concentration reductions on annual loads. The -DF dilution factor file shows the effect of flow reduction and/or hydrograph extension on dilution factors. The -SF storm flow file shows the effect of flow reduction and/or hydrograph extension on storm flows. The -DQ downstream water quality file shows the effect of flow and concentration reductions and hydrograph extension on downstream water quality. In this module, we learned that SELDM simulates concentration reductions, flow reductions, and hydrograph extension by BMPs. SELDM uses a black box approach to model the net effects of BMPs or series of BMPs rather than a process-based approach. SELDM uses the trapezoidal distribution and rank correlation to inflow concentrations and flows to stochastically simulate BMP performance. The BMP form is the last input form before the final run-SELDM form. It has 4 tabs to input general, hydrologic, and water quality information. All the SELDM output files show some effects of BMPs on flow and water quality.